Hello students, welcome to Study Life. Yes, board exams are approaching and the stress and the tension about the reactions of organic chemistry increases. So here Study Life brings you a solution to all these things. In this video, we are going to discuss in one shot all the various chemical reactions with respect to name reactions. So all the various name reactions in your textbook, we are going to quickly revise all the reactions. Yes, we have a big list you can see on the screen, right? Beginning from Finkelstein, Swartz, SANDMEYER'S, WILLIAMSON'S, Wurtz reaction. On the next one we also have crossed ALDOL, crossed CANNIZZARO'S, CLEMMENSON'S reduction, WOLF-KISHNER reduction, and many more reactions up till the final one, Felling's reagent test. So are we ready for this? A very important session, a very important discussion of various name reactions. So let's begin with the first reaction, that is Finkelstein reaction. Now what exactly is Finkelstein reaction? It is an example of halogen exchange reaction. So one halogen is going to replace another halogen and it involves the formation of alkyl iodides. The very important word is that it forms alkyl iodide. So that alkyl iodide is obtained when NaI reacts with RCl. So the reaction, the substitution is I is going to replace Cl and it will give you the formation of Ri, that is alkyl iodide. Now the example, now this was the general reaction, this we call it as general reaction. Now coming on to the example, the alkyl group we have taken for example is ethyl group. So ethyl chloride reacts with NaI in presence of acetone. Again, the reacting conditions are very important, and when this reaction takes place, it gives you the formation of ethyl iodide with the byproduct of NaCl. That is the substitution taking place. This reaction is termed as, yes, it is called as Finkelstein reaction. Moving on, the next reaction, Swartz reaction. Now this Swartz reaction is also an important example of halogen exchange, but here the halogen exchange will give you the formation of alkyl fluorides. Previously it was alkyl iodide, now it is alkyl fluoride, and that is prepared by heating alkyl chloride and bromide with reacting conditions of AgF, Hj2F, AsF3 and SbF3. And in this reaction, again the substitution, this is fluorine F will replace chlorine, and that gives you the formation of RF. So fluorine is replacing chlorine as you can see here, and that gives you the formation of RF. This is the formation of RF, and you get AgCl as the precipitate. Again an example of the same, CS3Br plus AgF. So whenever you get this name reactions and write notes on, you will be writing the statement, a general reaction and an example. This reaction is what is called as Swartz reaction. The next one coming up on the screen is the third important reaction, SANDMEYER'S reaction. Now in SANDMEYER'S reaction, you have a set of products. That is, you start with aniline first. Aniline will react with nitrous acid to give you diazonium salt. So that is benzene diazonium chloride. This benzene diazonium chloride will react with different conditions. Yes, what are they? CuCN will give you cyanobenzene. When it reacts with CuX, it can give you halobenzene, haloarine. When it reacts with Ki, it gives you iodobenzene. On hydrolysis, it gives you phenols. So these are the different reactions with SANDMEYER'S reaction coming up. The next reaction is when it reacts with fluoroborate. So benzene ring with N2BF4 minus, benzene diazonium fluoroborate gives you benzene ring with F, and this is again a new term, Bals-Scheiman reaction. So within SANDMEYER'S reaction, you also have Bals-Scheiman reaction when it is for fluorine. The next one, reacting with NaNO2, it gives you the formation of nitrobenzene. So benzene ring with NO2, that is called as nitrobenzene. So what are the different array of products in SANDMEYER reaction? Cyanobenzene, haloarine, iodobenzene, phenols, fluorobenzene, that is your Bals-Scheiman reaction. and the last one is nitrobenzene. The next reaction on your screen, a very important board question, Williamson synthesis. What is the significant feature of Williamson synthesis? That's a keyword. Simple as well as mixed ethers can be prepared. So this method is used for the preparation of both simple as well as mixed ethers. What happens in this reaction? Yes, the reactant is sodium alkoxide will react with sodium, that is alkyl halides. Sodium alkoxide and sodium phenoxide will react with alkyl halide and give you the formation of ether. So this is your sodium alkoxide will react with alkyl halide. So sodium alkoxide on reaction with alkyl halide gives you the formation of ether. Now this ether can be alkyl ether or it can be aryl ether. Yes, here you have the aryl ether also. Coming on to an example, sodium tert butoxide on reaction with methyl bromide. Now here something very interesting and very important. Na plus, you can see here, this is Na plus here. This Na plus will combine with Br. Now when Na is combining with Br, what is the product? You will get NaBr, and what is the final product here is tert butyl methyl ether. So in Williamson synthesis, as mentioned very clearly, both type of ethers are obtained. Which both type of ethers? Yes, you have the formation of simple as well as you have the formation of mixed ether. So you will get both the ether formation taking place. The next reaction is Wurtz synthesis or Wurtz reaction. Now in Wurtz reaction, it is alkyl halide, it's 2Rx will react with twice Na, that is sodium metal, in presence of dry ether, and this gives you the formation of RR, that is alkane. It gives you the formation of corresponding alkane. So this is a reaction where higher alkanes are obtained from lower alkyl halides. Now an example for the same reaction wherein you have a mixture of two different alkyl halides, something very important and a very different unique reaction where you use methyl bromide and you are using ethyl bromide, and this gives you the formation of, yes, mixture of products, ethane, then you have propane, and finally you have butane. So these are the three different products that you obtain in this reaction. That gives you the formation of ethane, propane and butane. Moving on to the next reaction. In the next reaction, that is Wurtz-FITTIG reaction. Now what exactly is Wurtz-FITTIG reaction? For Wurtz-FITTIG reaction, it is bromobenzene, benzene ring with Br will combine with CH3Br, methyl bromide and sodium metal. Now try to understand how exactly happens here the reaction. 2Br you have, those 2Br will combine with twice Na. So 2Na, 2Br, that gives you twice NaBr, that is the byproduct. What is left out? CH3 is left out. That CH3 gets attached here, and this will give you the formation of toluene. This is how you get the formation of toluene. So bromobenzene, benzene ring with Br plus CH3Br plus 2 sodium metal in presence of dry ether. Yes, what happens as mentioned, 2Na will combine with 2Br. So 2Na and this is 2Br, you can see here. This 2Br will combine with this 2Na and the byproduct is twice NaBr. What is the another thing that you are left out with? Benzene ring with CH3, and that is called as the formation of toluene taking place. So this is how toluene is obtained in this reaction. The next one, FITTIG reaction. Now in case of FITTIG reaction, what exactly is FITTIG reaction? It is chlorobenzene, yes, this is chlorobenzene, will combine with twice Na, sodium metal, and this gives you the formation of a diphenyl ring over here. This is the diphenyl biphenyl ring. So chlorobenzene on reaction with sodium metal in presence of dry ether gives you the formation of biphenyl plus 2 times sodium chloride. So this is the formation of biphenyl, and the name of the reaction, a very important one, FITTIG reaction. So see, this Wurtz reaction is one, Wurtz-FITTIG is another, and FITTIG is the third one. So you should be very clear with all these three different name reactions. The next one is KOLBE'S reaction. In case of KOLBE'S reaction, it is the treatment of sodium phenoxide with carbon dioxide at about 398 Kelvin. So when in sodium phenoxide reacts with carbon dioxide at about 398 Kelvin, first step, it gives you sodium salicylate. So benzene ring with OH and COONA, that is called as sodium salicylate. This sodium salicylate, then it is followed by acid hydrolysis. So when it undergoes acid hydrolysis, it will give you the formation of corresponding salicylic acid. So on reaction, it finally results into what is called as salicylic acid. So sodium phenoxide plus carbon dioxide at about 398 Kelvin at 2 to 6 atmospheric pressure gives you first sodium salicylate, and this sodium salicylate will now react with acid hydrolysis, and that gives you salicylic acid. So you can make a list of all the reactions that we are discussing right away, and you can write down the name of the reactants and name of the products. That will also help you to develop your more better understanding for this topic. The next reaction is REIMER-TIEMANN reaction. Now basically in case of REIMER-TIEMANN reaction, when phenol is treated with chloroform in aqueous sodium hydroxide solution, it will first form salicyl aldehyde, and this salicyl aldehyde is obtained in this reaction after the intermediate formation. Now let us first quickly understand this reaction. Now this is OH here, CHCl3 is here. So out of that CHCl3 and NaOH, this OH will be combining with H. So OH combines with H, gives you water molecule, and this Na will now attach with O. So Na gets attached with O and it becomes ONA, right? Next important thing, you have got CHCl3. Out of that CHCl3, CHCl2 gets attached here. So CHCl2 gets attached at the ortho position. So two things to remember, CHCl2 at ortho position and ONA gets attached at OH. So OH, H gets replaced by Na. Next reaction, in the second step, it again reacts with NaOH. So when it is reacting with NaOH, what exactly happens? One O from here will combine with CH. O is going to combine with CH. What does it gives you? It gives you the formation of, when this OH will combine, it gives you CHO. So here it is CHO formation, and along with that, this is here OH. So now this is called as salicyl aldehyde, or this compound can also be called as 2-hydroxybenzaldehyde. So in case of REIMER-TIEMANN reaction, what we get? We get the formation of salicyl aldehyde, or it is called as 2-hydroxybenzaldehyde. The next reaction, that is Friedel-Crafts reaction. Now in case of Friedel-Crafts reaction, you have got two types. One is Friedel-Crafts acylation, and the another one is Friedel-Crafts alkylation. We need to understand two things together: Friedel-Crafts acylation, Friedel-Crafts alkylation. Now here this is benzene ring with Cl plus CH3COCl. This is CH3COCl. Now in this CH3COCl, what exactly happens? First step, the COCH3, this portion, will combine at ortho position, and COCH3 will combine at para position. So this COCH3, this small portion, will be at ortho location here, and it is at para location here. So ortho and para, and that gives you the formation of, yes, it is 2-chloroacetophenone. Yeah, it should be 2-chloroacetophenone, and this is 4-chloroacetophenone. So that gives you the formation of 2-chloroacetophenone and 4-chloroacetophenone. The next reaction, Friedel-Crafts reaction. Now this is alkylation. As I mentioned, previous was acylation, where you have added the CH3CO group coming up, COCH3 group. Now here what we are doing is, we are doing Friedel-Crafts alkylation. So acylation, alkylation. Now coming to Friedel-Crafts alkylation, a very important condition in your board exams, it should be mentioned. That is, the reaction takes place in presence of AlCl3 as a catalyst. So let it be alkylation, let it be acylation, you need to specify that AlCl3 will be used as a catalyst. So here it is chlorobenzene Yes, reacting with methyl chloride. Again, the reaction will be at ortho as well as para position. At ortho position, if the reaction takes place, it is chlorotoluene formation, and at para position, it is going to be again 4-chlorotoluene formation. So ortho position and para position, the reaction takes place. The next reaction and the heart of the chapter of alcohol, the aldehyde ketones and carboxylic acid. Yes, the aldehyde ketones, carboxylic acid, you have the aldol condensation. Now, what is aldol condensation? Yes, it is the condensation of aldehydes and ketones which contains at least one alpha hydrogen atom. So very, very important word. For aldol condensation to bring about, alpha hydrogen atom is necessary. Second important thing, when this reaction takes place, so aldehydes containing at least one alpha hydrogen atom will react with, what do they react with? They react with dilute base. So they are reacting with dilute base like, what are they? NaOH, KOH and Na2CO3, any one of them. And it will give you beta hydroxy aldehydes or beta hydroxy ketones. That beta hydroxy aldehydes or ketones, from there the water molecule is eliminated. Very quickly we will try to understand this reaction. What exactly happens? Now this is ethanol. Now this is again another molecule of ethanol. This is the alpha hydrogen which will combine over here. When this alpha hydrogen is combining, it is now CH3 CHOH. Now this is your functional group, alpha carbon, beta carbon. To this beta carbon, what is attached? OH is attached to the beta carbon, and that is why it is called as beta hydroxy aldehyde. Yes, why beta hydroxy? This is the functional group CHO. Then you have the alpha carbon. The neighboring is the beta carbon. To that beta carbon, OH is attached. Now coming on to the IUPAC name. How will you give the IUPAC name? First, second, third carbon. On third carbon, it is OH. So it is 3-hydroxy. And total there are 4 carbon atoms. With aldehyde, it is butanol. So it is 3-hydroxy butanol. Next reaction is the removal of water molecule. Now when this water molecule is removed from here, this is the removal of water molecule. Now from this, when water is removed, what do I get? CS3 as it is, CH, because this OH is eliminated. No, I have only CH. So CS3, then CH, then again one more CH, and finally CHO. And this compound here, this is first carbon, this is second, this is third, and this is fourth. So this will give you the formation of but-2-enol, because at the second and third carbon you have a double bond. So but-2-enol. So that is how you get the formation of the compound but-2-enol. So here this is the formation of but-2-enol. The reaction is aldol condensation, a very important reaction for both aldehydes and ketones. Which aldehydes and ketones? The one which contains alpha hydrogen atom. So aldehydes and ketones containing alpha hydrogen atoms will give you the formation of first beta hydroxy aldehydes or beta hydroxy ketone, and again on removal of water gives you alpha beta unsaturated aldehydes. That is what is the alpha beta unsaturated aldehyde, but-2-enol. So that's the compound but-2-enol. The reaction the same way for ketones. Just now what we did was the reaction for aldehydes. Now the reaction for ketones. Now in the reaction for ketones, if it is ketones which is containing alpha hydrogen atom. Now how do you confirm whether it contains alpha hydrogen atom? A very simple trick I'll give you. This is your C double bond O, that is the ketonic functional group. Now through the functional group, if any carbon is attached, that carbon is your alpha carbon. So this is my alpha carbon or this is my alpha carbon. And that alpha carbon contains hydrogen, so it becomes my alpha hydrogen. So this compound will show positive test for aldol condensation because yes, it contains alpha hydrogen atom. So basically when I'm talking about alpha hydrogen atom, it should be carbon atom with the functional group attached to the next carbon, the alpha carbon. So let's start with the reaction here. CH3COCH3 with the next molecule. In the first step, what does it gives you? 4-hydroxy, 4-methyl, pentane-2-one, and that is what is the ketol formation. Aldol ketol, see the word now, aldol ketol, that is aldehyde group with alcohol OH, so it is aldol. Same way it is ketol. And in the next step, when water molecule is removed, it gives you 4-methyl pent 3-in-2-one. So the name of the compound is 4-methyl pent 3-in-2-one. How do you get this? Let's take an example. First carbon, second, third, fourth, fifth. Now at the fourth position you have got CH3. At the fourth position CH3, that is 4-methyl. Total there are 5 carbons, so it is pent. At the third position you have a double bond, so it is 3-in. And at the second position you have a ketone, so it is 2-ONE. So the name of the compound is 4-methyl pent 3-in-2-one. The next reaction, that is crossed aldol condensation. Now what is crossed aldol condensation? The basic difference between aldol condensation and crossed aldol condensation. Now here in case of crossed aldol condensation refers to the aldol condensation that takes place in between two different aldehydes or ketones. That's a substance of understanding, a very important keyword, that is two different aldehydes or two different ketones. Previously when we were talking about aldol condensation, the two examples that we discussed, both the cases aldehydes or ketones were the same ones. But here now it is two different aldehydes or two different ketones will undergo the reaction, and that is what is called as crossed aldol condensation. Now in this crossed aldol condensation, to begin with, let's take the two different aldehydes. Yes, which are they? Ethanol and propanol. Condition applied, both aldehydes must contain alpha hydrogen atom. So when we are talking about two different aldehydes, both the aldehydes are containing alpha hydrogen atom. Those aldehydes on self condensation, same molecule repeated twice. Self condensation is same molecule repeated twice, and obviously when you are removing the hydrogen, you are removing the hydrogen from alpha carbon. That is what is called as self condensation. The two products that you will get is but2-enol and 2-methyl pent2-enol. And when the same molecule is repeated with the different reactant, that is ethanol with propanol or propanol with ethanol, that together will give you the formation of two different compounds. One is called as 2-methyl but2-enol and the next one is called as pent2-enol. So these are the two different products which gets formed. The pent2-enol is formed and you can get the formation of 2-methyl but2-enol. The next reaction after the crossed aldol condensation is the CANNIZZARO'S reaction. Now for CANNIZZARO'S reaction, it is a self-redox reaction. When I say it is a self-redox reaction, the name has its meaning here. It is self-oxidation and reduction reaction on heating with concentrated alkali. Compare this with the previous one. There it was dilute alkali. Now here it is concentrated alkali. What is the another name for this reaction? It is also called as disproportionation reaction. Now here in this reaction, what exactly happens? It is the formaldehyde which will react with 50% sodium hydroxide. Formaldehyde on reaction with 50% sodium hydroxide will give you sodium formate and methanol. So that gives you the formation of sodium formate and methanol. The next reaction, crossed CANNIZZARO'S. CANNIZZARO'S reaction, crossed CANNIZZARO'S reaction. Now in crossed CANNIZZARO'S reaction, what exactly we have? It's a mixture of formaldehyde and another aldehyde which is a non-analyzable, and it is treated with a strong base. So when you are talking about CANNIZZARO'S, be very clear, reaction is with a strong base, and when this undergoes reaction, it gives you the formation of two products. One is formic acid and the another one is phenyl methanol. Now why phenyl methanol? This is a carbon with OH. Now the carbon with OH, one carbon, it is methane, and E is replaced by OL because of alcohol, so it is methanol, and on the first carbon phenyl group is attached, benzene ring with a bond, so it is called as phenyl methanol. So the total complete reaction in one shot, it is formaldehyde plus benzaldehyde to react with, and condition applied is concentrated NaOH in acidic conditions, that is acid hydrolysis, it is followed by, will give you first phenyl methanol and formic acid. So this is the reaction that we have. The next reaction is WOLF-KISHNER reaction and CLEMMENSON'S reduction reaction. Now basically, what is this WOLF-KISHNER and CLEMMENSON'S reduction reaction together? This is a reaction wherein you have the carbonyl group of aldehydes and ketones which is reduced to methylene group. So carbonyl group gets converted into methylene group and the reaction takes place in presence of zinc amalgam. So when I say it forms methylene group, means we are talking about formation of alkane, formation of hydrocarbons. So carbonyl group of aldehydes and ketones is reduced to methylene group on treatment with zinc amalgam and concentrated HCl, or the reaction can take place. Now this is for Clemmenson. Now or after this or whatever comes up, that is for WOLF-KISHNER. So for Clemmenson, I'll again revise this. For Clemmenson, the carbonyl group is going to react with zinc amalgam, and on reaction with zinc amalgam and hydrochloric acid, it will give you CH2 group. For WOLF-KISHNER, what happens? It is the reaction wherein the hydrazine will be reacting followed by the reaction with sodium hydroxide, and that gives you the final product. So let's begin with the reaction. Quite interesting, quite important. Now this is your carbonyl group plus 4H. Out of those 4H, 2 hydrogen atom combines with carbon. So see, there are total 4H, 2 hydrogen atoms are going to combine with carbon. This is 4H, here 2 hydrogen will combine with carbon. And the remaining 2 hydrogen atoms will combine with oxygen, and that gives you the formation of water molecule. So here this is 4H, here this 4H. Out of this 4, 2 hydrogen to combine with carbon gives you CH2, yes, this is CH2, and remaining 2 hydrogen will combine with oxygen, and that gives you H2O. So this is the formation of methylene group. Let's take an example to talk about this. Here in this example, CH3COCH3, that is a ketone called as acetone, will react with 4H in presence of zinc amalgam and concentrated HCl. Now 4H, 2H from here will combine with carbon. So 2H, when it combines with carbon, what do I get? CH3CH2, and the next CH3 is left out here. Now the 2 hydrogen atoms are left out. Those 2 hydrogen atoms will combine with this oxygen and give you the removal of water molecule. So together this is acetone giving you propane, CH3, CH2, CH3. The next reaction is for propanol. Now for the reaction of propanol, what exactly happens? This is CH3, CH2, CHO plus 4H. This is here plus 4H in presence of zinc and concentrated HCl. So here the reaction takes place in presence of zinc and concentrated HCl. So when this reaction occurs, finally what you get is you will get the formation of propane here. So this will give you the final formation of propane. Now this is the final propane that we get. So this reaction wherein propanol plus 4H in presence of zinc amalgam and concentrated HCl gives the formation of propane. Moving on to the next reaction, that is WOLF-KISHNER. Now this is WOLF-KISHNER reaction. In case of WOLF-KISHNER, it is used to synthesize straight chain alkyl substituted benzene, which is not possible basically by FRIEDEL-Crafts alkylation reaction. So there are some drawbacks of FRIEDEL-Crafts alkylation reaction which is removed by WOLF-KISHNER. Now here in this Wolf-Kishner, this is C double bond O, ketone, to combine with NH2 single bond NH2. So it can be aldehydic group or ketonic group. It's a carbonyl basically. So first step, it will give you hydrazone. So aldehyde or ketone will first combine with hydrazine to give you hydrazone. That hydrazone in the second step reacts with KOH, that is alcohol, or ethylene glycol, CH2OH, CH2OH, and that gives you the formation of methylene group. So again a reaction, very important, aldehyde or ketone first giving you hydrazone. That hydrazone in the second step will react with KOH, or it can be ethylene glycol, to give you the formation of methylene group, to give you the formation of alkanes. This is the example of the same reaction that we have. Say it is C2H5CHO propanol. First step, it will give you the hydrazone. This hydrazone in the second step undergoes further reaction and will give you the formation of propane. Now this was the reaction for open chain compounds. Similarly, you can have a reaction for closed chain. Now say for closed chain, here the example is ethyl phenyl ketone. That ethyl phenyl ketone will react with hydrazine, and first step, yes, what is that? Hydrazone is obtained. So it is ethyl phenyl ketone hydrazone, and this will then react with KOH and will give you the formation of N-propyl benzene. So this is the formation of N-propyl benzene. This is the product here, you can see benzene ring with CH2 and CS3. That is here the C2H5, sorry, this is C2H5. So benzene ring, CH2 and C2H5. So that is N-propyl benzene along with the removal of nitrogen gas. The next reaction coming up on the screen, that is a very important reaction, ETARD reaction. Now for ETARD reaction, we are using again a oxidizing agent. Now what is that oxidizing agent? It is chromyl chloride, and this reaction takes place in presence of a non-polar solvent. Which is that non-polar solvent? It is carbon disulfide. So here carbon disulfide is used as a non-polar solvent. First step, now this is toluene, will react with chromyl chloride. This is chromyl chloride, and that gives you the formation of, yes, that gives you the formation of chromium complex. So this is OCrOHCl2, OCrOHCl2. That gives you the formation of chromium complex. This chromium complex undergoes acid hydrolysis, and then that gives you formation of benzaldehyde. So this is the conversion of toluene to benzaldehyde. Now in this oxidizing agent used is chromyl chloride, and first step what happens is formation of chromium complex, a very big compound you can see on the screen. Yes, that is important, and you remember it, OCrOHCl2, OCrOHCl2. So that is the chromium complex, this one, this compound is your chromium complex. Now coming on to the next reaction, that is, yes, now begins a very important series of Hoffmann's ammonolysis. Hoffmann's reaction, a big list coming up, Hoffmann's reaction. Now in case of Hoffmann's reaction, it is RX, that is alkyl halide, to react with ammonia. So alkyl halide reacts with ammonia. Now here, if alkyl halide is in excess, that's a condition applied, that alkyl halide is in excess. So if alkyl halide is in excess, the reaction doesn't stop at one step. First it gives you primary amines. That primary amines will give you secondary amines. Secondary amines then gives you tertiary amines, and finally you get quaternary ammonium salt. So if excess of alkyl halide is used, you don't get only primary amines, you will get a mixture of primary, secondary, tertiary amines followed by quaternary ammonium salt. Now the question is slightly twisted. If excess of ammonia is used, then what? So if excess of ammonia is used, the reaction will stop in the first step, only forming primary amines. The further things will not take place. So you should know whether what is used in excess. Ammonia is used in excess or alkyl halide is used in excess. The next one, again a MCQ based question, the order of reactivity. Now what is that order of reactivity of alkyl halides? It is Ri greater than Rbr greater than RCl. So that is the order of reactivity. The next reaction in the series is Hoffmann's elimination reaction. Now what is Hoffmann's elimination reaction? Now again in this Hoffmann's elimination reaction, let's take this example here, N with a plus charge. When I say N is with a plus charge, what are the things possible? This CH2 CH3 is 3 times already attached, 3 times. CH3 CH2 CH2 is again one group. So total there are 4 groups. So for a nitrogen like this, if I say, there are total of 4 groups. How 4 groups? CH2 CH3 at 3 places, CH2 CH3 at 3 places, here also, and CH3 CH2 CH2 at this one place. So total there are 4 groups. This 4 groups will combine with AgOH. What is AgOH? Silver hydroxide. So when this reacts with AgOH or silver hydroxide, simple thing that happens is I and OH gets replaced. There is replacement for I and OH, and this gives you here OH minus. So this is here formation of OH minus. Now when this OH minus is formed here, this is your first product that you get. After this, the removal of water. Now this OH from here and H. So OH and H will combine together to remove water molecule, and what is that left out with? Yes, we are left out with CH2 double bond CH2, and that is called as ethene formation. Now some of the points on the left hand side of the screen is important as far as your exams are concerned. Just we'll have a quick go through for that as well. Ammonium hydroxide on strong heating undergoes beta elimination to give alkene. The reaction is called as Hoffmann's elimination reaction. The least substituted alkene is obtained as major product. So if there is confusion, you will have 2 different products, major and minor, and who decides it? The decision is taken by something called as SANDMEYER'S rule method, SANDMEYER'S elimination method. So this is about Hoffmann's ammonolysis. After Hoffmann's ammonolysis, Hoffmann's elimination reaction. Now the next reaction is Hoffmann's exhaustive alkylation. Now this Hoffmann's exhaustive alkylation is very similar to your Hoffmann's ammonolysis. Here what you have is primary amines, yes, reacts with Rx to first give you secondary amines. That secondary amines again reacts with Rx to give you tertiary, and tertiary gives you tetra-alkyl ammonium halide, and this tetra-alkyl ammonium halide is also called as, yes, quaternary ammonium salt. The another name for this is quaternary ammonium salt. This is the complete set of reactions that we were talking about. Methylamine first gives you dimethylamine, coming with the names. Methylamine first gives you dimethylamine. Dimethylamine then gives you trimethylamine. And finally, trimethylamine gives you the formation of tetramethyl ammonium iodide. So it's the formation of tetramethyl ammonium iodide, which is also called as quaternary ammonium salt. So here conversion of methylamine to tetramethyl ammonium iodide that takes place. Moving on to the next reaction. Yes. Now this is another Hoffmann's family coming up, Hoffmann's bromamide degradation. Now the word is degradation. Now what is that degradation? That is something very important to understand. It is the conversion of amide into primary amines. Amide gets converted into primary amines containing 1 carbon less. So when amide is getting converted into amines, that primary amine formed contains 1 carbon less. Now here the reaction to begin with. Now this reaction is brought about by warming the amide with concentrated KOH solution. So what we are using here is concentrated KOH solution. So let's talk about the reaction. RCONH2, which is called as acid amide, plus Br2 plus 4KOH. Now here this is RCONH2, this carbon just try to cross check. RCONH2, here it gives you only RNH2. So that carbon gets reduced, that carbon is not appearing in the product now here. This means one carbon is less, and this carbon which is less is what is that? Degradation. That is why the name is Hoffmann's bromamide degradation. Coming on to the example of the same, CH3CONH2, that is acetamide here, will combine with Br2 plus 4KOH. Now this acetamide has got 2 carbon. The amine that is formed has 1 carbon. See this, acetamide has 2 carbon, but the amine which is obtained has only 1 carbon. This means 1 carbon reduces, and this is what is called as Hoffmann's bromamide degradation reaction. Now this will give you plus the byproducts. Yes, the byproducts are twice KBr, K2CO3, and finally at the end we have got the formation of 2 H2O molecules. So here you can see 2 H2O molecule is in the product. The next reaction, that is carbyl amine reaction. Now this carbyl amine reaction is a very important reaction. Many times in your boards, in your even competitive exams, you have ample of questions with this. What is basically carbyl amine test or carbyl amine reaction? It is a test for identification of primary amines, 1 degree amines, may it be aliphatic, aromatic, whatever. So aliphatic or aromatic primary amines, on heating with chloroform, it gives a foul offensive odor. That foul offensive odor is of alkyl isocyanide or aryl isocyanide. So it gives you the formation of alkyl isocyanide or aryl isocyanide. That is called as carbyl amines, and that is why the test is called as carbyl amine test. Now comes a very important statement on your screen. This reaction is a test for primary amines. That's what I was trying to tell you, that this is a characteristic reaction of only primary amines. So here RNH2, that is primary amines, plus CHCl3 plus thrice KOH. First step, it gives you RNC, that is alkyl isocyanide, plus thrice KCl plus thrice water molecule. So this alkyl isocyanide which is formed has an offensive odor, and since it is having an offensive odor, that's the reason why we say that that offensive odor confirms that the amine is a primary amine or 1 degree amine. So that's the formation of 1 degree amine. The next one is MENDIUS reduction reaction. Now what is MENDIUS reduction reaction? It is the reaction for preparation of amines. So primary amines can be obtained by the reaction of alkyl cyanides with sodium and ethanol. So the condition applied on the arrow, sodium and ethanol. This reaction is known as MENDIUS reduction reaction. Now for this reaction, RC triple bond N plus 4H gives you RCH2NH2. So now again say this trick to remember. Out of 4 hydrogen, 2 hydrogen with this carbon and 2 hydrogen with this carbon. Simple to remember. 2 hydrogen with the first carbon, 2 hydrogen with the second carbon, and that gives you RCH2NH2. So that gives you the formation of primary amines. Another possibility of the reaction, rather than starting from alkyl cyanide, you can start from amide as well. So if it is amide reacting with 4H, similar story, that is 4H, 2 carbon will combine with 2 hydrogen will combine with carbon, and remaining 2 will combine with oxygen, and that gives you the byproduct. What is that byproduct? Water molecule. So 2H from here with O will give you water, that's the byproduct, and 2H here when it combines, it gives you CH3, then 2H getting added, CH2, and finally it is NH2. So that gives you the formation of ethyl amine. The next one is HINSBERG test. Again, this is a question generally asked in the exams. for what is HINSBERG test, or with the help of HINSBERG test, how will you differentiate between primary and secondary amines? To begin with, what is HINSBERG test? Benzene sulfonyl chloride is known as HINSBERG's reagent. So when I say HINSBERG test, HINSBERG reagent, benzene sulfonyl chloride, it is called as HINSBERG reagent. In this reaction, it is ethyl amine which reacts with benzene sulfonyl chloride, and in the first step it forms N-ethyl benzene sulfonyl amide. How does the reaction takes place? Let's try to cross check. Now this is benzene sulfonyl chloride on the screen. The reactant will combine with primary amines C2H5NH2. Now this is Cl will combine with H. When I say Cl will combine with H, that will give you the formation of HCl. And what is that you are left out with? This bond continues with NHC2H5. You can see here NHC2H5. So this is how you remember the reaction. See this again, S double bond O is given out. Cl will combine with this H. The byproduct is HCl. And what is left out? NHC2H5. This NHC2H5 is what is seen in the reaction. Yes. Now this is the first step. Now very important statement is mentioned here. The hydrogen atom is attached to the nitrogen in sulfonylamide group, and that makes it strongly acidic, and hence it is soluble in alkali. This H I am talking about. So this H makes it acidic or provides acidic character, and that's the reason why it is soluble in alkali, or that's the reason why it reacts with alkali. Next is then what happens with secondary. Now for the secondary amines. Now for secondary amines, now this is C2H5, C2H5NH. Now this H will combine with Cl. H and Cl will give you here HCl. Now here can you see any H remaining? No, there is no H remaining over here. And that's the statement that N-dimethyl or diethyl benzene sulfonylamide does not contains any hydrogen atom which is attached to nitrogen. Hence, it does not dissolve in alkali. So previously, it was dissolving in alkali because of the hydrogen which provided acidic character. Now here it is not dissolving because there is no acidic character present. So this is how you get the reaction for secondary amines. So see this HINSBERG test itself giving you difference in the test for primary amines and for secondary amines. Moving on to the next reaction, that is Rosenmund reaction. Now in Rosenmund reaction, what is the Rosenmund reaction used for? Yes, preparation of aldehydes. So here acyl chloride RCOCl plus H2. When it reacts with H2, it will give you the formation of aldehydes. Now in this reaction, again to be very clear, one hydrogen has to get added to carbon. So there are two hydrogen atoms. One hydrogen gets attached to carbon, and the another hydrogen atom that I have, that another hydrogen atom will combine with Cl, and that's the byproduct HCl. So what I get here is, I'll get here RCHO plus HCl. What is that RCHO? RCHO is called as aldehyde. So in Rosenmund reaction, acyl chloride is reduced to corresponding aldehydes. What is prepared? Aldehyde is prepared by using palladium catalyst poisoned with barium sulfate. So on the arrow that you have mentioned, that is PDBaSO4. What is that PDBaSO4? PD is palladium catalyst poisoned with barium sulfate. Stephen's reaction. Now this Stephen's reaction is again for the preparation of aldehydes. So nitriles are reduced to imine hydrogen chloride by stannous chloride. Now here you are using stannous chloride SnCl2 along with hydrochloric acid. So two things together to remember, SnCl2 and HCl. Let's see the reaction. CS3 C triple bond N. This is called as ethane nitrile plus 2H. Out of those 2H, 1H with carbon, 1H with nitrogen, and HCl. So this is now, see this, CS3 CH double bond NH and then HCl will combine with acid hydrolysis. when this undergoes acid hydrolysis, will give you the formation of ethanol plus NH4Cl. Same reaction can be taken out with benzonitrile or benzene ring, where it gives you the formation of benzaldehyde. So benzonitrile in the first step gives you benzamine hydrogen chloride or hydrochloride, which will further give you the formation of benzaldehyde. And this is the general equation or the general reaction. So Stephen's reaction, many a times it has been asked in many of the exams, and a very important reaction. But then keywords to remember: SnCl2 and HCl. When the reaction takes place, imine is formed, that is CH double bond NH is formed, and along with that imine HCl gets attached, and that is what is called as imine hydrochloride. That imine hydrochloride in the next second step undergoes hydrolysis, and that gives you the formation of alkanyl, that is ethanol. Moving on to the next reaction. Now coming on to Dow's process, a preparation from phenols. Now this is chlorobenzene is fused with NaOH at high temperature. What is that condition? 623 Kelvin, 150 atmospheric pressure, and that gives you the formation of phenols. Directly phenols are not obtained. Stepwise reaction. First it will give you sodium phenoxide. What is that sodium phenoxide? This is O minus Na+. So first sodium phenoxide, that sodium phenoxide on reaction with acid gives you phenols. So the reaction, chlorobenzene is fused with NaOH at high temperature and pressure. And what is that condition? 623 Kelvin and 150 atmospheric pressure, and it obtains phenols, or it gives you phenols. Gattermann's reaction, lot of reactions coming up. So Gattermann's reaction, I hope you all are revising, you're just cross-checking the things from the book as well. So just revise this very properly. Gattermann's reaction, yes, it is the reaction for benzene diazonium chloride. This is benzene diazonium chloride, which will give you the formation of chlorobenzene. This is ArCl chlorobenzene. So ArN2 plus X minus. This is benzene diazonium chloride. When it reacts with copper powder and HCl, it gives you chlorobenzene. If it is reacting with HBr, then it will give you bromobenzene. So for the Gattermann's reaction, you can have chlorobenzene formation or you can have bromobenzene formation. Yeah, the next reaction here, this is arene diazonium salt, that is called as azo-coupling reaction. Now in this azo-coupling reaction, arene diazonium salts, when they are treated with certain reactive aromatic compounds such as phenols or aromatic amines, it gives azo compounds. So what are azo compounds basically? Azo compounds are the colored complexes, and these compounds, when they are formed, they will give particular color. You can see here orange dye mentioned. So benzene diazonium chloride, when it reacts with phenol, it will give you the formation of this orange color dye. Let's see the reaction. Now this is benzene diazonium chloride on reaction with phenols. Now when this reacts with phenol, one of the H from here will combine with Cl. So when I say H combines with Cl, that gives you HCl. First step. Secondly, this N double bond N, this group is called as azo group. This is called as azo. So this is now here para, fourth position. This is the fourth position. So para, OH is present, so it is hydroxy. This is N double bond N, so it is called as azo, and finally it is a benzene ring. So see the words para, hydroxy, azo, benzene. The next reaction after para, hydroxy, azo, benzene of the similar type. Only difference, instead of OH here, now you have NH2. Rest everything is same. Previously it was OH, so it was called as phenol. Now here it is NH2, so it is called as aniline. And in the product also, what is the change? Instead of calling it as para hydroxy, now we are calling it as para amino. This is para amino azo benzene. The next reaction after para-amino-azobenzene is for the Schiff's reagent. Now these are the three tests, if you remember, from your aldehydes, which is shown only by aldehydes and not by ketones because they contain reducible hydrogen atom. So the test which contains reducible hydrogen atom, Schiff's reagent test, Tollens reagent test, and the last one you have is Fehling's solution test. So let's talk about the Schiff's reagent test first. Now what is Schiff's reagent test? Alcoholic solution of aldehyde is treated with few drops of Schiff's reagent. And what is the color change? This is what you should remember as far as your exams are concerned. The color change is pink, red, magenta color appearing, and that confirms the presence of aldehydic group. So if that pink color, red color or magenta color appears when the Schiff's reagent, that is para-rosa aniline, will combine with the particular test of aldehyde or the substance, if it gives you the color, then it confirms that aldehyde is present in the given sample. Second important thing, the Tollens reagent test, also called as silver mirror test. Now if an aldehyde here reacts with Tollens reagent, that is the silver mirror test we are talking about. What is Tollens reagent? One line question. What is Tollens reagent? Ammoniacal silver nitrate. That ammoniacal silver nitrate is called as Tollens reagent, and when it reacts with aldehyde, if you get a silver mirror formed at the outer side of your test tube, in the test tube the outer side silver mirror gets formed, that means it is showing a positive test for Tollens reagent. So the aldehyde is oxidized to carboxylate ions by Tollens reagent and Ag plus gets reduced to Ag. Now you can see here this is Ag plus, 2 times AgNH3 twice plus will give you the formation of, it gives you the formation of Ag. So this is 2 times Ag. So here Ag plus ions getting reduced to Ag, that is where you say it is a silver mirror test. So this is the silver mirror test shown only by aldehydes and not by ketones. The next one is Fehling's solution test. Now in case of Fehling's solution test, when a mixture of an aldehyde and Fehling solution is reacted with boiled water or hot water, a red colored precipitate is formed. That formation of red colored precipitate itself shows that it is containing reducible hydrogen or it is containing aldehydes. So this is the Fehling's solution test. So this is what exactly happens with Fehling's solution test. Now in this reaction, as I mentioned, for Fehling solution you will have the reaction of Fehling's test. For Fehling's test, it is aldehydes combining with Fehling solution to give you carboxylate ion. So here we complete with all the chemical reactions in your textbook of the 12th standard class, and in that we have completed right from all the chapters the name reactions. Hope this video will help you all and give you a quick revision for the topics that is needed as far as board exams are concerned. For such innovative topics, innovative ideas and learning, students stay tuned with Study Live. Thank you.